So welcome everybody. Happy to have you here. Welcome to Software Engineering 637, software testing. Hopefully you're all in the right place. Pretty big group this year. We have about 33 or 34 students signed up at the moment. It's a few larger. I usually go about 30. So nice to have you here. I'll leave the choice up to you. I kind of prefer it if you go ahead and if you're able and comfortable with your video on. I kind of like to, it gives me a little more feeling that we're all in the, kind of all in the class together. But I'll leave that up to you. There's no requirement to have video on or anything. This is a pretty informal class. I know it always feels awkward to interrupt, over a video class, but please feel free if you've got a question or you've got a relevant comment you'd like to make. I would really do appreciate your involvement in the class. Okay, so SWE637 software testing. So this class is going to be about about 75% testing theory, about 25% testing practice. So if you were thinking, great, I'm going to learn JUnit. Well, you are actually going to learn JUnit, but we're really not going to be focusing too much on the, on the hands dirty of how do you write tests. As a graduate level class, we'll be digging deeper than that and looking into a lot of the theory behind why do we test the way we test and what are some other ways that maybe we could test that, frankly, as you talk to your friends, neighbors, and coworkers, they'll be like, what? I've never heard of that. And that's okay. So we're going to talk a lot about criteria-based testing and somewhat about how we can apply that theory to practice. The lectures are going to tend to be pretty theoretical. We're going to have some in-class exercises that are also relatively theoretical, and then we've got a set of homework assignments or projects, or call them whatever you like, across the semester, and that's really where you mostly get to do some get to dig in and do some hands-on work and actually do some test implementation. So this class doesn't have any strict prerequisites. I think that 619, which is like Java and data structures and OO programming, I think that's listed as a prerequisite. You don't actually have to have it in order to sign up. I don't really care if you've taken 619 or not, but to be successful in the class, you're going to have to be at least reasonably familiar with Java. With a few exceptions, we're not really going to like dive down into the weeds of weird object-oriented inheritance stuff. We're mostly going to be using Java in a pretty straightforward way. But you do want to understand data structures, right? We're going to be using a lot of data structures as examples, so lists and queues and things like that. You want to understand control flow graphs, a little bit of compiler theory background. Again, we're not digging down into parsing and code generation and optimizing, but you want to understand how code turns into a control flow graph. I need to understand a little bit about formal logic, not too much, and a little bit about discrete math. Again, not too much, but a little bit of exposure to those things, and you should be all set to be fully successful here in the class. So a little bit about me. Hi, nice to meet you all. My name is Bob Kurtz. You can, depending on what you're comfortable with, the first semester I taught, I encouraged people to just call me Bob. I think there was like one person in the class that felt they could bring themselves to do that. You can call me Bob, you can call me Professor, you can call me Dr. Bob or Dr. Kurtz. When you call me Dr. Bob, I always think of the Muppet, doing surgery on telephones and stuff, which is probably lost on a lot of people because, I'm old. But again, it is pretty formal. I don't insist on being called Professor or Dr. Kurtz or whatever. So you can address me as you feel comfortable doing so. So I have a Bachelor of Science in Computer Science from long ago at the State University of New York. Then I did a master's degree in software engineering, the very program that a lot of you are in here at George Mason, graduated in 2000. And then at the end of 2018, I graduated with my PhD in information technology, again from GMU. It was a great degree program. I love the process. I hate the degree program name. I'm a little bit biased myself, and when we talk about information technology, I tend to think about people plugging in routers. And you know, I don't have a PhD in plugging in routers and configuring firewalls. But there wasn't a PhD in software engineering, at least at that time. I'm not sure what the current scenario is. Um, my research and dissertation work, I used a lot of machine learning to look at the practicality of improving mutation testing. We'll talk about mutation testing at the end of the semester, and so I won't spend a lot of time on it now. But it was very interesting, and if you're in the PhD program and don't have a research topic yet, or even if you're in the master's program and looking to do a a dissertation-based master's, um, this is actually a really good area of research with a lot of, there's still a lot of openings and a lot of work to do there. And if you enjoy working with Paul Amon, I'm sure he'd be happy to take on somebody to kind of further that work we've been doing. Since I graduated, as I explained to Paul and Jeff, and they were asking me to teach a class before I graduated, and I told them I could not work, be a student, and teach a class. Likewise, I can't work and teach a class and keep on doing research. So that research field has kind of been sitting there for a couple of years. So again, if you're interested in something that's kind of fun, and machine learning is pretty cool, software testing is fun, otherwise you wouldn't be here. You might want to consider whether you want to pick up those things and run forward with them. So my experience, I'm an engineering fellow in software engineering at Raytheon Technologies. I've been there for a little over 25 years. Most of my background is in software engineering, embedded systems development, software testing, a lot of background in airborne intelligence and management systems and things like that. Had a comment from the class review comments at the end of the semester last year, where one of the students was like, I wish the professor would talk less about aerospace stuff and more about commercial software development. And that's a fair comment, and all I can really say is that when you want to be an author, everybody will tell you, write about what you know. And when you want to be an instructor, teach what you know. And I don't know commercial software development, and I'm not going to pretend to, and then just kind of look silly for those of you who do commercial software development and know better. So a lot of the examples that I use will be out of like the aerospace realm. So outside of work, when I'm not doing, when I'm not working, when I'm not teaching, when I'm not doing other stuff, I actually live down in Southern Virginia. After 30 years up in Northern Virginia in Fairfax and Loudoun County, I'm down in Southern Virginia at Smith Mountain Lake, where I enjoy boating. I've got a couple of retrievers, 2 golden retrievers and a flat-coated retriever, who's kind of an uncommon breed that's like the older cousin of the golden retriever. And I enjoy playing with them and doing some bird hunting and some other training with them. When I'm not doing those things, I'm not a big gamer. I know that there's probably a lot of people here who are. I don't usually spend too much time there, but I do occasionally like to get sucked into Kerbal Space Program, probably the most fun game ever for hardcore engineers. And I've also started doing a little bit of Flight Simulator 2020, which did cause me to buy a new laptop because my old one couldn't even run it. So some diversions. So this, as an example, if you've been on Piazza, I know that several of you have already done your own intros, but I'm asking on Piazza, there's a thread there for assignment 1. Homework assignment number 1 is not a hard one. Just do a short intro. Tell us a little bit about who you are, what you like to do, post a picture, tell us a little bit about your software development and your software testing experience. And that's all we're looking for the first assignment. So a question I inevitably get, is this a hard class? And my initial answer is, well, it's a graduate class in engineering. Of course it's a hard class. On the other hand, it's not really a terribly hard class. And I go out of my way to actually not make it that hard. So here are the grade distributions over the last 3 semesters. And you can see that, it's not that hard to get an A in this class. But there's, a non-zero number of B's, C's, and a couple of F's. So, there is some work that you have to do. I think that you're all certainly well cut out for it. I mean, you're here in a graduate program. I don't go out of my way to make this a lot of extra work, right? There's things that we need to cover. The assignments I mentioned, the homework assignments or projects if you prefer, they are to give you an opportunity to, get a little experience with some of the things that we're talking about. They are not purposely made to be big. They're not purposely made to be hard. The last one is, probably the biggest and the hardest of them. Many of the others you can probably bang out in a night or two, and that's okay. So online resources, as those of you who I'm talking to have obviously figured out, lectures are on Zoom. I did notice that as I was connecting to this, I had a shortcut using the Zoom meeting ID that was in the syllabus, and when I got there, I was like, it's 5 minutes to 5, and I'm the only one here. And then I realized that the Zoom ID in the syllabus is wrong, but the link was right. So I'll correct that in the syllabus, and hopefully there aren't a lot of people out there trying to connect with the Zoom ID instead of the link. Blackboard. I really don't like Blackboard. You probably all don't really like Blackboard either, but we're kind of stuck with it. So quizzes, the final exam, those will be happening on Blackboard. Your grades will be posted on Blackboard, but that's about it for Blackboard. We're going to do all of our other, we're going to do everything else on Piazza. So lecture video will be posted there. Lecture slides will be posted there. We'll be having whatever discussions we're having, and I do like an active discussion. That's great. We'll be doing that on Piazza. You should all now have access to the Blackboard classroom and to the Piazza room. If you don't, then drop me an email after class and I'll make sure we get that fixed. Piazza changed their business model this last semester because their usage went up by about 1 bazillion. And they are now contribution funded. And so you'll be getting some prompts to ask you to contribute some money to Blackboard. I'm not going to tell you not to do that, but you don't have to do that. And in fact, GMU will be purchasing a Piazza enterprise license at some point during this semester. So Piazza is going to get their money off of us, and I sent them $10 because, okay, fine. But don't feel compelled to donate any money to Piazza. They're going to have an enterprise license through Mason, so they'll get taken care of. So the textbook, Introduction to Software Testing, the second edition by Paul Alman and Jeff Offit. This is the red one, not the older yellowish green one. Like all textbooks, it's an expensive textbook. It's also available electronically. I kind of like a physical textbook, but boy, that electronic version sure is nice to be able to look stuff up in. So buy the real one, buy the electronic one, borrow it off somebody who took the class last semester, whatever you like. But we will be, we're not going to be like reading out of the textbook in class, but I think you will want that as a resource. I mentioned that all of the syllabus is already on Piazza and on Blackboard. The lecture slides will be posted on Blackboard. I tried to get them up a couple of days before class. Sometimes I realize, Thursday, oh, I haven't posted that yet. But I tried to get them up there before class, along with the class exercises. If you go to my website, you can also find all of the slide materials from previous classes. So if you want to look ahead, feel free. Do understand that in the week before coming up to class, I generally look through the materials and sometimes I update them. So if you look ahead on that site, you may see things that are slightly different from what we actually end up doing in class, but it won't be a whole lot different. So here's our class schedule. This is on the posted syllabus as well. Really the only two things that I want to point out, as I'm sure you already know, there's no spring break. And for this class, as the schedule falls, there's no reading week. So we are basically just 15 straight weeks, 14 classes, and then right into the final, 15 consecutive Thursdays. So office hours, I'm an adjunct professor. I don't have an office. Also, I'm not in Northern Virginia anymore. So I don't have any office hours. However, you should feel free to contact me by email, by Piazza Chat, which can be public or private as you see fit. I'm happy to respond to you that way. If we need to have an in-person conversation, I'm happy to set something up by Zoom so that we can talk. I just don't have regular walk-in hours. We do have a graduate teaching assistant. I have asked him to set up some regular hours that he will be available also virtually. I don't have those hours yet, but when I do have that, we'll get that posted and get the syllabus updated. So what's a typical class look like? As you saw from the email, or maybe you waited around for half an hour before I connected, I feel like it's really hard. I mean, 2.5 hours is a long time, or 2 hours and 40 minutes, right? The actual class length. That's a really long time to be sitting staring at a screen and trying to keep your level of attention up. And for me, it's a really long time to talk to a screen. I don't get the same energy talking to a screen and postage stamp pictures of all of you that I do when we're actually interacting. So as a result of that, what I've done is I've shortened the class a little bit. So we'll be starting at 5 each week, and I'll generally be stopping right about 7. There may be once in a while we may go over a few minutes, but my objective is to stop at 7 and not go all the way to 7:10. So we're shortening it up just a little bit, just to kind of help everybody keep rolling. So typically, we're going to start off each class with a really brief review of whatever the quiz or the assignment was from the previous week. That's usually about a 5 or 10 minute thing. Then it's lecture time, usually till about 6. Then we'll take about a 10-minute break, depending on exactly where the clock falls. After that, we come back at 10 after 6, quarter after 6, whatever it works out to be, and we spend that time until 7 doing some group exercises and classes. So you guys will be working in small subgroups. There's going to be 5 different groups going through the exercises, and then there will be time for us to all get back together at the end and go through and do at least a little bit of out briefing, so that each group, usually each group, sometimes we don't make it to everybody, gets to talk a little bit about what their results were and why they thought that was the right answer. So it kind of gives us a chance to work together as a group a little bit. The first semester I did that last spring. It was a little bit rough. Last semester, the fall semester, I think we got it worked out pretty smoothly. By the end of the semester, people were really seeming to really enjoy that, and so I'm hoping that'll be good for all of us. So I do want to talk about grading for the class. The class grade is based on 4 things. We have no midterm exam. Instead of a midterm exam, we have a quiz every week. Not this week, of course, so there will be 13 quizzes. I'll come back and talk more about them in a minute, but those quizzes altogether in the aggregate are worth 30% of your grade. The homework assignments or projects, those are worth another 30% of your grade. The final exam is 30% of your grade. And then class participation is the last 10% of your grade. And I want to point out that class participation, 10% of the grade, that's actually a big chunk, so that is important. And so I'll talk in just a minute. I've got an upcoming slide on what class participation means and how you can work on cashing in on that part of the grade. So the grades here. 97 and up, that's an A+. 90 to 96 is an A. You can read this as well as I can. You'll notice that I do pluses, but I don't do minuses. This is kind of a little personal annoyance that I had in my, in my graduate degree. I had an A or an A+ in everything except for one class that I got an A- in, and I was really annoyed to finish up with like, what is that, like a 3.97 or something, and I was like, seriously, come on. So no, I don't do minuses because I think that's just a way to, cheat you a little bit. So it's either an A or an A+, or a B or a B+, or a C. No D's, graduate class. Please at least make a C, otherwise it's bad. Grades are absolute. I don't grade on a curve, but I do want to explain that a little bit. While I don't grade on a curve, I do reserve the right to adjust grades for any particular quiz or any particular assignment or the final exam. And I will only adjust grades upward. You know, if everybody gets a 10 on the quiz, congratulations. If everybody gets 100 on the final exam, terrific. If everybody in the class finishes with an A+, I'll be delighted. So I'm not curving anybody down. If, however, I give a quiz and it's like, wow, everybody got a 5 out of 10 on this. If that happens kind of on an overwhelming basis, then I kind of have to look back at that and say, okay, where did I go wrong? And maybe I'll decide to drop that quiz. Maybe I'll decide to +4 it. And if I decide to make a grade adjustment, that grade adjustment will apply to everyone. So if I decide to add 2 points to a quiz and you got a 10, congratulations, now you have a 12. Okay, so it's just very fair across the board, and no downgrading, only the possibility of upgrading if I feel like somewhere along the way there, you know, I kind of missed out. It becomes obvious to me that, all right, that's a question we really didn't cover, or I missed something, or that was way harder than I thought it was. With a couple of semesters behind me, things are pretty dialed in now, so I don't expect too much of that, but I just want you to understand how that works. So back to quizzes that are 30% of your grade. Every week we will have a quiz. They have been 30-minute quizzes. That proved to be a little tight with the online format last year. I may adjust the length a little bit and make them a little longer. These quizzes are not during class. The quizzes are on your own. Each quiz becomes available at the end of class, and you have to complete it by 5 p.m. the following Tuesday, to give the TA and I enough time to grade them before the following class so that we can review them. So you've got 5 days starting at the end of class in order to get each quiz done. There will be a total of 13 quizzes. I'm going to take your lowest 3 grades and drop them. So you'll be graded on your highest 10 quizzes. So if you happen to miss one, don't panic. At the same time, I don't generally give makeup opportunities for quizzes. If you missed it, you missed it. If you got a 3, you got a 3 out of 10. And normally that just kind of all falls off the bottom because I'm dropping the lowest 3. If you have some special circumstances, you know, I need to be on travel for work, or I have to be out of the country, or, you know, I'm really sick, let me know beforehand, and I'm happy to make adjustments for special circumstances as needed. So quizzes are typically based on the previous week's lecture, and they typically follow pretty closely what the in-class assignment was. So if you got through the in-class assignment and you understood what we were doing, you're probably in pretty good shape for the quiz. I'm not guaranteeing that it's always a one-to-one matchup, but it's often the case. It's often based pretty heavily on what we did as part of the in-class work. So the quizzes are on Blackboard. They are open book, they're open notes, they're open anything except other people, right? It's work that I expect you to do on your own. But yep, you can have the book, you can have notes, you can Google Stack Overflow, or you know, you can do whatever you want. But I do expect you to do the work on your own. Yep, quizzes are 10 points. Occasionally I'll have a 1-point bonus question on the quiz, you know, if I feel like there's something where, hey, I'd like to see if people can, you know, kind of stretch that a little further and really get it, you know, see if they can show a deeper understanding of what's going on, then there may be a bonus point on there. And that's just, you know, again, simply bonus. So if you end up with 105 out of 100, you know, for the total quiz score, that's fine. Those 5 extra points, they'll get figured right into your grade. So homework assignments or projects, this is another 30% of your grade. There are 6 of them. Each assignment is worth 10 points. I typically don't have bonus points on assignments, just the way it works out. And again, as I mentioned earlier, these are really supposed to be a chance for you to take the theory that we've been learning in class and try to turn that into a little bit of practice and actually do some test implementation using some of the techniques that we've talked about in class. You can do assignments in groups, groups of any size. I will tell you that from experience, seems like 2 to 4 is the best size. You know, when there have been groups of more than 4 people, it tends to devolve into no one knows what anybody else is doing, and the assignment ends up incomplete because everybody thought somebody else was doing something. However, you know, if 20 of you want to get together and do an assignment, that's okay. But there's only 1 grade given to each of you. So if the assignment is a, you know, and is a 9 out of 10, then all 20 of you get that 9. And so I'm not going to get into, you know, I'm not going to get into looking at who contributed what part of the assignment. You're all just going to share the grade. Assignments are due at the start of class on their due day, and they are reduced by 50% if they're late for the first week, and after a week it's just a 0. So do try to get those in on time. And then the assignments are not weighted equally. They get a little more complex and a little more in-depth as we go on. As I mentioned, the first assignment is just to post a post an introduction of yourself, so that's not real hard. So they're weighted so that of the total value of the assignments, the first through third assignments are 10% of the assignment score, and then 20, 20, and 30, which hopefully adds up to 50, 60, 80, 90. Good, 100. So class participation, I promised you I'd come back to this. Class participation is 10% of your grade. And that can really make a big difference. Last semester, there were some really happy people and some really unhappy people, and a lot of their happiness was driven by their class participation grade. So how do you get those, you know, how do you claim those points, basically? It's pretty simple. The first way and the easiest way is just to be engaged in class, and particularly in the group exercises. When you're working as a group, I'm going to be jumping around in groups, and I'm going to be looking at, okay, who's the one sharing the screen? Who's the one guiding it? Who's actually involved in active conversations, right? Who's participating in this exercise? Who's volunteering to outbrief the exercise to the class? That's probably the best and easiest and most straightforward way. But this is a distance learning class. There is no requirement for you to be here on Thursday nights in this class. You can do this on your own time. You can watch the recorded class video. You can look at the slides. You can go through all the work on your own. That's fine. If you do that, how do you make your class participation? And really the answer to that is mostly Piazza. Start up a conversation, right? Ask a good question. Provide an answer for somebody else's question. Bring up something that you saw in the news, you know, bring up a topic that you saw that, you know, that revolves around or is associated somehow with software testing, right? Bring some interesting things to other people's attention. And that's a good way for class participation. And so to clarify this a little bit, because it says so in the syllabus, but doesn't say here right now, class participation is basically every week I'm going to score people as, you know, you participated with something, so you got a point, or you didn't and you don't get a point. And at the end, we add them all up. So it's as simple as that. Oh, and the last thing for class participation, find and fix an error in my slides. You know, I'm not perfect, and my slides are not perfect. They're, again, having done it for a couple of semesters, it's dialed in pretty good, but there were 3 good corrections last semester. That came, you know, for people having found an error in the slides. And I really appreciate that because I want them to be correct. So, you know, class participation points are, you know, I'm very happy to give those out for any slide corrections that come in. The final exam, the last 30% of your grade, that will be an online exam, much like the quizzes. It'll be on Blackboard. It'll be worth 100 points. It'll have a 5-point bonus question. It's cumulative. It covers topics from the entire semester. It's time limited. The past 2 semesters, I've made it 60 minutes. I've kind of concluded that that's a little bit too short, but it won't be more than 90 minutes. So it's time limited, and that is the one thing in class that is synchronous. So that final exam will be that last Thursday starting at 5 o'clock. If you can't make the final exam, and these things do happen, you got to let me know first, right? University policy, as you all probably know, an unexcused absence on the final is an automatic F, which, by the way, is not how any of the Fs that you saw on the chart happened. So make sure you talk to me first. You know, if you're sick, if you're have some other conflict, if you have another final at the same time, which seems unlikely, but it's happened, talk to me beforehand. We can definitely work something out. I don't want you to collect an F for having missed the final exam. So in-class exercises, I've talked about them several times. I want to describe them a little more now. They're actually not worth any % of your grade, right? So you don't have to be there. As I did mention, it's a great way to get class participation credit, but it's going to be basically the second half, or maybe a little less than the second half of each class. And so we're going to work these assignments in groups. I'm going to be assigning the groups, which, you know, if you're here with a bunch of friends and you're like, I really want to work with all my friends. Nope, I'm going to switch up and you're going to work with some new people. These are not turned in, they're not graded. They will be, you will have an opportunity to talk about what your answers were at the end of class. And then the quizzes, of course, are typically based on this. So doing the class exercises usually puts you in a pretty good spot for quizzes. I think I pretty much said all these things already, but you know, the first line is sort of my overriding thing. You know, I only teach graduate classes. I don't teach undergrad classes. I don't teach high school classes. I don't teach middle school classes. We're all big kids now. I expect you to know and figure out what's good for you and how you best want to do things. I don't take attendance. You can come to class, you can watch the videos later, you can manage this class however you want, and that's okay with me. But remember that class participation is 10% of your grade, so figure out how to, you know, figure out how to claim some of that. So other topics, if you have a disability accommodation, don't work directly with me, work with the Disability Services Office. They will contact me and I will make whatever adjustments are necessary to support that. GMU has a strict honor code. I have had more than one serious cheating problem in this class, and I've only been doing this for 3 semesters. I was very, very disappointed when those happened, and it kind of ended up working out poorly for people. So, you know, don't do that, okay? We're big kids. We can take classes on our own. So, last of all, I'd like to welcome you to Bugwarts. Here's the Bugwarts Castle, and this is where the group exercises come in. I'm going to split you up by groups. Got to call the groups something, so I decided to go with the Harry Potter theme. Not that I necessarily am all that into Harry Potter, but like lots of people in the class probably don't understand American football, and nobody else besides me probably cares who's racing in the America's Cup this year. So, you know, it's a way to come up with a set of teams. So we're going to be working the in-class exercises in groups. Your groups are going to be by your Harry Potter group. When you take the first quiz, you're going to be assigned randomly into a group. Now, depending on how the random assignment works, I might have to move a couple of people around so that the groups are reasonably even in size. And then we're going to have a little friendly competition. We've got the Bugwarts House Cup going on here. So each of those groups, each of those 5 groups will earn House Cup points for the best work on an in-class exercise, the first submission of a quiz or an assignment, the highest score on a quiz or an assignment, the highest final exam grade, fixing slide errors gets you there, and then the group with the highest score at the end of the semester gets 1 extra point on their final grade. And 1 extra point might not seem like much, but if you had an 89.1, that 1 extra point can make all the difference. So just trying for a little fun. All right, so that's all I've got on class introduction. Any questions on, any questions on what we talked about here?
Yeah, I've got one. Do you encourage us to try and do the assignments with the same groups that we're assigned for the in-class stuff, or do you want us to work with separate people?
I don't care either way. In the past, nobody has done that. Really, it was only last semester that I specified the groups. Previously, we kind of tried to all do the assignments together, and it was just too many people and didn't work. So last semester was the first semester I had the exercise groups. No one really ended up doing the homework assignments with those same groups. But if you and your group would like to do that, I'm totally fine with it. Typically, it ended up being groups more like 2 or 3 people, where these groups, with 30 people in the class will probably be, 6 or 7. So they might be a little big for the homework assignments, but if you'd like to do that, go ahead. Anybody else? All right, so
Professor, would you be updating the House Cup scores every week so that we can see how we're doing?
I will be updating the House Cup scores. Yes, I will be updating them every week, and at the beginning of class when we do the quiz out brief, typically the last slide on the quiz out brief will be what the current House Cup scores are. And we had a lot of good competition last year. I mean, the Gryffindors were off to an early lead, and then the Slytherins led through most of the semester. And in the end, the Hufflepuffs just took off in the last 3 or 4 weeks and just won the whole thing.
Thanks, Professor. And then secondly, for the participation points, you mentioned, a good way to get those is during class, but then another way to get them is on Piazza. So
yes,
will the week after a class basically count toward the previous class's participation point? Basically, how are the weeks on Piazza broken up?
Yeah, so that's a good question, and I don't know that I'm really all that formal about it. But typically, what I'll do is I'll kind of add that up, usually like on Wednesday night before class, or sometimes right before class. So roughly speaking, it'll be this week's points will start after this class and go up until the start of the next class, more or less.
All right, got it. Thank you.
Sure. All right, so let's talk about software testing. Why do we test software? Okay, I guess before I go any further, I've been assuming all along without ever asking that you can actually see my slides.
Yes.
Yes.
Good, thank you. So why do we test software? So a little bit about, current testing. Software essentially defines the behavior of whatever the thing is that the software lives in. And obviously the software market today, it's huge, right? It's much bigger, it's much more competitive. It has so many more users than, even 10 years ago. You're running absurd amounts of code in your smartphones, in your headset, in everything around you. Software is everywhere. Embedded software is increasingly everywhere as well. Aircraft, air traffic control systems, your Apple Watch has a ridiculous amount of software in it. Ovens, remote controls, Internet of Things has been putting software everywhere. We're appliance shopping for our new house. I was looking at refrigerators last week, and these new Samsung refrigerators basically have this giant iPad on the front of the refrigerator door where you can leave electronic notes for the family, and they've got cameras inside. You can be in the grocery store and bring up your camera of inside the fridge to figure out how much milk you have. I'm not sure that I want the rest of the world hacking their way into my fridge, so I'm not convinced it's a good idea, but it's out there, right? Software is everywhere. So the industry, as a result of that, as just the volume and the criticality of software, is really going through a revolution on how to do testing and what testing means to the success of software projects. So an interesting quote from Mark Harmon. He's a researcher at Queen's College in London. Software is a skin that surrounds our civilization. And I wonder whether that's accurate or whether it's really becoming more the bones and muscles themselves. But again, it's everywhere in everything, from things big to things small. So a couple of definitions, and these are definitions that we're going to be using consistently throughout the class. So first is a software fault. And a software fault is some static defect in the software, right? It's some error, some mistake that has been put into the software. That plus should be a minus. That, you know, that A should be not A, something like that. Then we have a software error. A software error is an incorrect internal state of the running software that happens as a result of reaching the fault. And when I say reaching the fault, I mean just the software execution, right? The software executes the faulty piece of the code. That's reaching it. That software error may result in a software failure. And a software failure is some externally observable incorrect behavior with respect to what the software should have been doing. So if I had a calculator and I hit 2 + 2 = and it came back with 5, that is an externally observable incorrect behavior. It should have been 4. So faults in software are equivalent to basically design mistakes in hardware. Unlike hardware, which can wear out and break down, right? Software doesn't wear out and break down. So we don't have any, we don't have any aging problems in software. We don't have things that break because you've run the software too many times. Okay, you might be able to come up with some weird edge case where that's not strictly true, but it's basically true. So looking at some examples of faults and failures. So if I go to the doctor and I say, you know, doctor, I'm coughing all the time. You know, that's an observable external thing. It's a thing that I noticed. I have a headache. Okay, maybe that's not externally observable. You can't see that I have a headache, but I can see that I have a headache, or I can feel I have a headache. That's my failure. I've noted a failure. And so I'm going to go to the doctor and, you know, I've got this cough. Something is wrong. I see that something is wrong. I'm not behaving the way I should be. The doctor is going to do a bunch of tests. He's going to test my blood pressure. He's going to do blood work. He's going to do whatever. And he's looking for errors. He's looking for some incorrect internal state within me. And if we can find enough errors and figure out what they mean, we may be able to determine the fault. Oh, well, the fault is, you know, I have the flu, or the fault is that my pancreas isn't producing the right amount of whatever it is that pancreas produce, because I'm a software engineer, not a medical guy. I'm not sure that I know. So we try to, find the fault. And then once the fault has been identified, then we can actually try to execute some kind of repair on that fault. So I use that as an analogy. Of course, in a lot of ways, it's a poor analogy, because a lot of medical problems are either from external influences or physical degradation, and software, as I said, generally speaking, doesn't really wear out. Yeah, I see the comment, AWS puts out an upgrade and breaks all your own code. Yeah, that's not uncommon, right? A new operating system, a new library release, and your code is broken, but it didn't wear out. It got broken from some external thing. So let's look at a concrete example. Here we've got a class in Java, or excuse me, a method function in Java. It's we're gonna give it an array of integers, and it's going to count up the number of zeros in that array of integers and return the number of zeros. And so we can look at this and we can see, okay, it's got a fault. The fault is that it should start searching at index 0 of the array, not index 1. So we had somebody write this who was familiar with some other language that counts arrays starting at 1 instead of starting at 0. So that's our fault. Now, can we execute that fault? Can we reach that fault? Well, what if we put in this array, 270? Our expected result is 1. that it found 1, 0 in there. And if we run this, the actual result that's returned is 1. So we don't have a failure. We do have an error because on the first iteration of the loop, the array index I is 1, where we would have expected it to be 0. It should be 0. 0 would be the correct internal state. So the internal state is wrong. The code reaches the fault, and that fault causes an error, a bad internal state. However, because of the way this test happens to be written, that doesn't result in a failure because it returns 1 and we expected it to return 1. Can we find a test that will result in a failure? Sure, not too hard in this case. We put 0 as the first element in the array, and this time the fault is the same. When the test is executed, it immediately causes an error because the internal state is incorrect, right? The array index value is 1 instead of 0. So that is an error. That error carries through to the end, and in the end we return 0 where we expected it to return 1. So now we have a failure. So before I go on, any questions about faults, errors, and failures?
Professor?
Yes.
So I feel like fault is very similar with error.
So the fault is something that exists in the software code itself. The error is in the software's running state, right? So you can have a fault with software that's not running, right? I can look at source code and I can see a fault. I can't have an error in source code, right? In the source code listing. I can only have an error when the program is running and something about the internal state isn't what I want it to be, right? So that's the difference between the two. The fault is a static thing. The error is a runtime thing.
Okay, thank you so much.
Sure. So what about bugs? What's a bug? As far as I've been able to determine, this Thomas Edison quote is actually real. I mean, I wasn't there. I can't vouch for it myself. But this is the oldest reference to bug that I have ever seen. I've previously seen stories about, oh, well, you know, when they were building ENIAC in the 1940s, right, the first big electronic computer, it was sparking or giving wrong answers, and they found that a moth or a fly was caught in it, and so it was called the bug. And that's a good story, but it seems like Thomas Edison predates it. You know, calling bugs as such little faults and difficulties are called. And then we can go back even further to Ada, Countess of Lovelace, who, as you probably all know, is generally considered to be the first computer programmer working on writing what are essentially programs for Charles Babbage's mechanical computers in the, somebody help me here, 1850s, 1860s, something like that. The 18 part is right anyway. Talking about, you know, herein may lie a possible source of error. The card, or if the actual mechanism is unerring, the cards, which are what the instructions were, may give it the wrong orders. And that is exactly a software fault. So, you know, these concepts are, you know, remarkably not new. So the term bug, it's usually used informally, right? I use it in day-to-day conversation. You probably all use it or have heard it used in day-to-day conversation. What does it really mean? Does it mean a fault? Does it mean a failure? Does it mean an error? And if you actually ask the person who used the word bug, they may not even know, right? They may not even be able to answer that question. Okay, I'm not actually sure what I meant. So this is kind of a, you know, it's a squishy word that can mean a lot of things to a lot of people. We would like to have a set of words that are precise and that eliminate confusion. So generally speaking, we will not be using the term bug here in this class, but instead we'll be identifying things as faults, errors, or failures. So software failures are expensive. We can go back to at this point, very old, right? A 20-year-old report from the National Institute of Standards and Technology that identified software defect costs at up to $59 billion a year in the US alone. And that's 20 years ago. So just imagine what that number must be today. You can find a few, a few specific things that have numbers put on them. Usually when this happens to companies, they are very reluctant to talk about it. So it's really hard to get good data. But imagine if you have a web application failure, I mean, that could cost you millions of dollars per hour in downtime. The numbers are huge. And a semantic report from 2007, and this is increasingly true, right? Most security failures are now in the application code, or most security vulnerabilities, excuse me, are now in the application code. Gone are the days when attackers are targeting, your router or whatever. They're now attacking your application code because that's where most of the defects are. That's where most of the opportunities are to do a buffer overrun attack or an SQL injection attack or some other kind of thing to gain access to your system. It's mostly at the application level. So I'll go over a couple of my favorite big-time software errors. Here we have from the mid-1980s, Therac 25 radiation therapy machine. Due to a software defect or a software fault, I guess I should use my own terminology, the machine delivered 100 times the amount of planned radiation and killed 3 patients. This is, to my knowledge, the first example of a fatality due to software, or at least due to a software failure. 1996. 1996 was a really bad year for space. 1996 started off with the European Space Agency's new heavy lift booster. Doing a space launch, was reusing the guidance system from their previous generation of boosters, which was highly reliable. However, the Ariane 5 system took a different flight profile, which caused an integer overflow in their downrange tracker, which resulted in rocket instability and self-destruct, destroying the mission. 1999, sorry, it was 1999 that was the really bad year for Mars. 1999, NASA lost 2 Mars missions, both due to software failures. Mars Climate Observer was lost due to an improper conversion from metric to what are we calling non-metric these days? I mean, it used to be called standard, but I don't think we can call it that anymore because metric is usually standard. Imperial, whatever. Pound force seconds to Newton seconds. The conversion was done incorrectly, and the mission actually just missed Mars completely. The Mars Polar Lander, same year, 1999. Had a software defect that shut down the landing engine prematurely. The landing engine was supposed to shut down when a little feeler switch on the landing gear hit the surface, and that would automatically shut down the landing engine. However, during the descent, they deployed the landing gear, and the vibration made the switch just go tap, 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 and the software did not properly account for the fact that the switch might momentarily tap, and so it shut down the lander engine, and the thing crashed and made a crater on Mars. 2002 to 2009, Toyota and Lexus vehicles with their unintended acceleration problems tracked back to, among other things, problems in the engine control computer. So we had 89 documented people killed in that, making it among the worst software defects from a human safety standpoint. 2003, overloaded transmission wires blacked out most of the Northeast US and Eastern Canada. 2007, first deployment of F-22 Raptors from Hawaii to Okinawa as they crossed the anti-meridian, right, plus minus 180 longitude, their navigation and fuel management systems shut down. Fortunately, they were flying with tankers and were able to visually follow their tankers back to Hawaii. It's a little embarrassing. And then the granddaddy of them all, 2018 and 2019, 2 Boeing 737 MAX crashes. This is actually attributed to a lot of things, and poor flight crew training is probably the biggest one, but also, you know, inadequate system design and inadequate imagination on how the system could fail resulted in these crashes in which 346 people were killed. Boeing lost untold amounts of money as a result of this, and these aircraft are really just now being returned into service. So big deal. Plenty more examples out there for those of you who care to look. If you happen to know of any or come across any interesting ones, post them on Piazza. So the takeaway is we have to do a better job as an industry and as professionals in making our software dependable. And so testing is one way to assess the reliability and dependability of software. We can't test quality in, but we can at least use testing to get a better view of what the risk level is on the software that we're testing. So now in the 21st century, we've got a lot more safety critical software. We've got a lot more real-time software, a lot more embedded software. You know, your pockets are full of it. Smartphones, car key fobs, you know, I mean, the most mundane things are powered by embedded software. Meanwhile, enterprise software applications are getting bigger. They're integrating more and more things. They're easily up into the tens of millions of lines of code. Operating systems, you know, Microsoft Windows hit over 10 million lines of code a decade or more ago. I have no idea what it's at now, but it's enormous. And we have lots of new platforms. And when you look at mobile apps, right, you've got 500 different versions of Android out there, all slightly different, right? The test environment is incredibly complex. And there's an expectation of incredibly high reliability. You know, if your iPhone shut down once a day, I mean, you would quickly decide that it's unusable. So what does all this mean to us? Software testing is more important. And so we need to think about, right, as software professionals, what are we trying to test and what are our test goals? I'm going to skip that because I really never come back and talk about it. And I don't want you worried about which one verification means and which one validation means, because I can never remember it myself. But there are two separate concepts here, right? And the one concept is, how well does that software or that product do the job that you need it to do? And the second and oddly separate concept is, how well does it fulfill the requirements that were put on it when it was built? And those two are not necessarily the same thing. All right, so let's talk a little bit about test process maturity. And I know that the first assignment talks about this and asks you to talk a little bit about what your test process or your organization's test process maturity is. And so we've got 5 levels here. So at level 0, there's no difference between testing and debugging. I write some code, I play around with it in kind of a haphazard way. If I happen to see that it didn't do something right, I try to figure out how to fix it. But I don't have any, you know, I don't have any defined process. I don't have any defined goals. Level 1, we're kind of taking it up a notch, and now we've decided the purpose of our testing is to show that our software is correct. Well, that seems reasonable. Right? It seems like a reasonable goal to prove that our software is correct. However, software is incredibly complex. As we get further along down this, you know, towards this goal, working towards this goal of proving that our software is correct, we start to understand that that's not really a reasonable goal. I mean, given some piece of real world software, it's sufficiently complex that I can never really test every possible case. Can I test every single thing that the Android OS can do on every single platform that it might be able to run on? That seems like an unreasonable thing to try to actually achieve. So let's turn it around. Sure, go ahead.
When you say correctness in this case, are you referring to, I'm thinking back to SWE619, where correctness of software referred to, does it adhere to the contract?
Yeah, to its contract. You could look at it a couple ways, right? And that kind of goes back to the verification versus validation. Adhering to its contract is something that we can test, at least at the low level, right? At the unit testing and collections of units level testing, we can test that something adheres to its contract. It's much harder to test that something satisfies its suitability. And then as soon as you put a human in the loop, you know, I'm now taking keyboard input or mouse input. Now the universe of what can happen just kind of explodes to be hugely bigger. Can I test every possible thing that someone could type into this text field? Probably not. So in level 2, we try to, okay, let's reverse that. Let's take a separate view. If we can't prove that the software is correct or that it does work, let's see if we can prove that it doesn't work. And if we can't prove that it doesn't work, then we'll assume that it does work. Well, that actually seems reasonable too. And if we're trying to prove that things don't work and they were able to find them, that at least gives us something specific that we can go fix. So this is a reasonable process. But again, it's kind of hard to have a, you know, it's hard to have a stopping function, right? What's my completeness criteria? When do I stop testing? I'm never really done experimenting with different ways to try to make the software not work. So as we, you know, kind of gain that maturity and gain that understanding, we move towards this, I guess, kind of middle ground, but also this more mature thinking of, it's impractical for me to show that my software works in all circumstances. It's impractical for me to attempt every possible way that I could to make the software not work. So what am I really trying to do here? If I can't prove the software is correct, and proving the software is incorrect is an infinite length process, what am I left with? And really what I'm left with is, well, I'm trying to reduce the risk of using this software, right? I'm trying to get a certain level of, or certain reasonable level of confidence that this software is suitable for the task. And what that reasonable level of confidence is may vary considerably depending on what the software is. You know, if we're writing, you know, you know, an iPhone game, okay, you know, users get annoyed when the game crashes or when it doesn't work right. And that's bad, right? That hurts our market position. It limits our sales. We get bad reviews. More people don't buy our game. On the other hand, if we're, you know, writing an airline or autopilot, the consequences of failure are considerably higher. So the justifiable cost and effort that goes into that testing is also considerably higher. So we can also abstract that a little further into level 4. And in level 4 thinking, we're really now talking about testing as a mental discipline, right? So software or software testing needs to be part of the way that we're doing business. And in level 4, we're trying to make this a lot less adversarial. Up till now, especially in level 2. In level 2 in particular, I've got typically developers and testers. And the developer's job is to write something and throw it over the wall to the testers. And the tester's job is to break it and throw it over the wall back to the developers. And the developers hate the testers. And the testers probably don't think too highly of the developers either. Here in level 4, we now have our entire team, and we've got our entire team focused on this objective of risk reduction as the overall team, right? And we're trying to kind of internalize our processes so that we're always doing our testing with kind of an eye on the risk reduction and the overall program quality. Oh yeah, I had breakout slides for each of these. I've probably talked to most of these, so I'm just going to skim these to see if there are any important points that I want to bring up that I didn't already. So yeah, level 0. There's no difference between incorrect behavior and mistakes, right? Faults, failures, errors, whatever. It's all just bugs. Doesn't really help us develop software that's reliable. You know, we're just kind of taking a haphazard approach at finding things. And generally speaking, if you're an undergrad computer science student, this is largely what you have probably done and largely what you've been taught to do. And I know there's a little more emphasis on testing at the undergraduate level now than there used to be, but you know, I remember many classes where you know you have some requirements and then you write the thing, and then the night before it's due, the professor sends out the data set that he or she is going to be using, and of course it's got all kinds of weird stuff in it that you never thought about, and so you're in this debugging fest all night long before you turn in your project. That's not really a great way to go about things. We can do better than that. So level 1, again, correctness is impossible to achieve. What if we don't have any failures? Do I have good software or do I just have bad tests? I don't really know because I don't have any way to measure my tests. We don't really have a strict goal. We don't have a stopping rule, which is a problem. We don't have a formal test technique. This is better than not doing anything, but it's not great. Level 2, we're trying to show failures. As I said, looking for failures is a negative activity. Now we've got 2 opposing teams. They both hate each other's guts. Not a good place to be. However, this is how a lot of software companies work, and I've certainly spent many years working in this kind of environment. So level 3, now we're understanding a few more things, right? We're understanding that testing can't show that the software is correct. It can only show examples of software that's incorrect if we happen to catch it. We understand that whenever we're using software, we're incurring some risk. And we start to understand big risk versus small risk and how that justifies big testing versus small testing investment. So there are some software companies, and you know, this says a few enlightened software companies, and I think that was probably true 5 years ago, but I think that this is a lot more common now over the last few years. And then level 4, like I said, mental discipline. We have people on the test side now, instead of being the second-class citizens that they used to be, especially in level 2, where their job was to just break stuff, now those test people, they can be first-class citizens on the project, right? They can be program leaders. They can be people who are driving what's happening on the project. And the expertise of those testing people, you know, now we're kind of one group. The developers and the testers, they're one group. We can now be sharing expertise back and forth. We've got a much more cooperative relationship. And this is kind of more the way traditional engineering works, right? If you're a civil engineer and you want to build a bridge, you don't build a bridge and then hand it over to the testers who drive heavier and heavier trucks over it until they break it and tell you to go back and build a bigger bridge. You know, you're working with the test people, you're working with the material science people, you're getting the bridge done right the first time. And sure, we'll do some testing on it because, you know, we're not that crazy. But we're bringing the test people and their test expectations into the design process so that we're designing the right bridge in the first place. So, you know, who are you and where are you at? And so our goal in this class is to help you become change agents in your organization, to help you become a level 4 thinker. You know, it may be optimistic to think that you're going to go back to your company, especially if you work at a big company, and say, hey, I took a class in software testing and now we're going to change everything. All right, that's a little optimistic. But if you can write better code and better tests and get a few people writing better code and better tests, then you're making an impact, you know, on the world of software. So we want to think about, right, if we're at level 4, we want to be thinking about what's the purpose of each test? Why am I writing that test? What do I hope to achieve by it? And if I don't know why I'm writing any particular test, it probably won't be that useful. So we need to have some test objectives, and we need to have some test requirements. What are we attempting to achieve by our tests? One way to look at that is, what are our planned coverage levels? If we have a testing criterion, how much of that criterion are we planning to meet, right? How much testing do we have? That gives us a couple of good things. Or rather, if we don't have that, we have a few bad things. If we don't have a stopping point, then when do we stop testing? And usually the answer is when the ship date comes, or when we run out of testing money, right? The date criterion, right? Well, look, we were supposed to ship on February 1st. It's January 28th. You're done testing. However, whatever you found, however far you are, it doesn't matter. You're done. Not a very mature way of doing things. So testing has a cost. Testing has a big cost. Testing is expensive. The problem is that not testing is even more expensive. Testing is often the most time-consuming and the most expensive part of software development. If we're writing good unit tests, for example, I might have 4 or 5 times as many lines of test code as I have in the code that I'm testing. So if I wrote 1,000 lines of code as part of my product, I might have 3 or 4 or 5,000 lines of code to test that. I mean, that's a massive investment. But if I don't test it, that can be even more expensive, because if it breaks, you know, my sales may go down, my customers might die, depending on what it is that I'm building, right? This is a very bad thing. And you can't plan for your tests after the development is complete. That's just too expensive and too long. We need to be integrating testing in with our development as we go. So testing costs more the later we do it. So if we look at this chart, it's a little complicated, but the gold parts are saying, okay, if we look at the traditional life cycle of software development, we work our requirements, then our design, then we code it, then we test it at various increasing levels, and then we use it. We're mostly putting the defects in. We're mostly putting in the faults at the beginning. We're mostly finding the faults near the end. And the red line shows what it costs to fix faults as we find them. If you find your fault in the requirements phase, it's really cheap to fix. Oh, we should reword that requirement. There, done. If you find it in the design phase, it's a little more expensive, but not a lot more. If you find it while you're coding, it's not hard to fix code that we're working on right now. If you find it during functional testing or system testing, where we've got all these components together in the lab, we've put the whole thing together, now we're testing it in real world scenarios, now we found a problem. Well, we're going to have to redo all that testing. I mean, that just got expensive. If we find it in operational use, now it's really expensive, because now we've got 10,000 of them out there the customers are using. We have to update them all, right? If you're doing something on a phone, that's easy. You push an update. But if you've got an embedded system, now I've got to recall, 5 million Fords so that we can put a software fix in at the dealer. Yeah, I know Tesla does it online, but not a lot of other people do. Really expensive to find things. So we want to be shifting left our testing. We want to be finding things earlier. So, in summary, my goal as a tester, I want to find and eliminate faults as early as I can in the software lifecycle. That's going to improve my quality, reduce my cost, and preserve my customer satisfaction. Okay, that's it for kind of our overview on WhyTest. We're 6:15. Let's take a 10-minute break. We'll come back at 6:25. A couple minutes for any questions or discussions about what we just went over, and then we'll launch into our group exercises, although this week we don't have groups yet, so it'll just be class as a whole. Okay, so 10-minute break. See you back 6:25.